It may seem strange now, but in the late 1940s and early 1950s, many people believed that it was possible to survive a nuclear war, or perhaps even to win one. There were only a few atomic bombs in existence, they were relatively small, and they had to be dropped from airplanes that were slow enough to defend against. It wasn't until the early 1960s, after the development of ballistic missiles armed with hydrogen bombs, that people began to think of mutually assured destruction as the only possible outcome of any such conflict. During World War II, the U.S. military had access to all of the great scientists it wanted across the Allied nations. The Manhattan Project alone had more than 24 past or future Nobel Prize winners working on it. But after the war ended, those scientists made their way back to universities or private enterprise, both of which paid better than working for the government. The RAND Corporation was the military's answer, a private, non-profit company started with leftover money from the war and originally having only the U.S. Air Force as a client. Its mission was to help the Air Force fight effectively in the new world of technological warfare, not just by inventing better weapons, but by developing the strategy and tactics needed to use those weapons. Game theory was an integral part of RAND from the beginning, as its experts tried to understand the threats posed by the Soviet Union. John von Neumann was hired as a consultant at the end of 1947. He was soon followed by another brilliant mathematician, John Nash, who extended von Neumann's minimax theorem to prove that a rational solution exists, called the Nash equilibrium, even in two-person games that aren't zero-sum. Soon RAND was drawing in academics from all over the country to study game theory, including Abe Gershik and David Blackwell. By the spring of 1949, Blackwell had already become known at RAND for his work on the mathematics of duels. You might have seen a duel depicted in a movie or an old cartoon, or if you're familiar with American history, or musical theater, you'll know that Aaron Burr killed Alexander Hamilton in one. The popular image of a duel features two combatants, usually men in old-fashioned formal wear, standing back to back, walking a few paces apart, and then turning to fire pistols at each other. Blackwell wasn't interested in shooting anyone, of course, but he found some interesting mathematics in the contest. RAND and its Air Force client were interested as well, because the mathematics of a duel could be applied to other forms of combat, fighter planes against bombers, planes against ground defenses, or even nations menacing each other with nuclear weapons. A duel is a two-person zero-sum game, which according to von Neumann means that it has a rational solution, the minimax. In the basic scenario, Blackwell assumed that each player only had one bullet, and that the duel occurred over a fixed period of time. A duel has three possible outcomes: win, lose, or tie. Let's say that the value of winning is 1, the value of losing is -1, and the value of a tie is 0. The final value of the game, the minimax, will be somewhere between 1 and -1. The simplest way to represent such a duel mathematically is to give each player a fixed probability of hitting the other. But that's not the most realistic way to look at it, nor the most interesting. Blackwell explored the ways a player's probability can change over time. Maybe the accuracy improves as the player has more time to aim. Or maybe the accuracy gets worse as the player grows more nervous. With conditions changing over time, the players must find their best strategies. Each must find the best time to pull the trigger, a time with the maximum chance of hitting the other player, without waiting too long and giving the other player a chance to shoot first.